Hello everyone. What you see below is an Xbox AC adapter already partially disassembled. What has happened to this one here is that my brother accidentally plugged it into a 220 volts outlet when it is supposed to be powered where you see their input 100 to 127 volts AC. So yeah, similar thing to what happened to my dryer. If you guys have seen my one of my previous videos where I disassemble or basically tear down a timer from the dryer machine, that we the same thing happened. I mean, it was accidentally plugged into the wrong outlet and then it burned the timer. So looks like it runs through the family. This plugging into the wrong outlet thing. My brother did the same thing with this PSU from his Xbox. Um, I understand there are various models, so let me just take a shot of this just for those wanting to know specifically which model this is. I think it's like the third model in a four different models list. Um, so yeah, I mean it's already disassembled. I'm gonna have a look at it. I have already done some cleanup because it was filthy with dirt, the little cooler here. So I have already cleaned it up a little bit. You need special Torx drivers to remove the screws. I'm not quite sure if it shows well on camera, but there's a little there's like a little pin inside the Torx cavity. So you have to have one of these drivers with a little hole in it. I think it's to help with the placement when automated assembly. I don't know. Anyways, I didn't have these sort of keys, so this sort of driver, so I had to buy it. But just a detail. So I'll get into troubleshooting it and then we take from there. All right. So let me just begin by saying I'm no expert or no I don't have much experience in fixing these things. So but there are some obvious things already here when I look. So there's a fuse in here. I have already checked and it's fine. You might hear the beep of my mood meter. Uh, Here's the input protection caps, I guess. So I'm gonna have a look at those. There's a mob in here as well. I'm gonna have a look at that. Uh, there's another one here, I guess, and then a bridge rectifier. This should be like pass transistors or something. Yeah. Uh, a bunch of caps in here. So yeah, I'm gonna be looking at it, but I think I'm gonna actually remove the shooting. I have to desolder it from the board, just to be able to follow the tracks below because I'm in a probably someone with a bit more experience can follow the circuit without any further disassembly. But I think I need to do that just to follow the circuit better, follow the tracks beneath the board. So yeah, that's what I'm gonna do, and then we take from there. Oh, and just a quick comment. I was going to desolder this, but if you can see, this is pretty bad. I mean, the pad has been lifted already, and in here, it's not even connected. In here, if I take my plier and I, you see, it's already off. My brother did send this to a technician to try a fix before he sent it to me. Oh man, I'm not quite sure if what this guy has done. I hope he hasn't screwed it up much further, but I think he's definitely been in here trying to desolder these things, and he has done a awful job. So, oh man, it's bad when you take something that someone else touched and you don't know what else or what exactly they did. Oh man, let me have a look at it. Okay, so I took the shoot off. It's pretty clear what the guy did. I mean, it was a high. I mean, it would have to heat it up substantially before he could remove this without damaging the pads. And oh man. Anyways, there's some ugly stuff going on here just by doing a visual inspection. So here you see there's like these joints look ugly. I don't know if the guy did anything in here. There's also some ugliness in here. Also, again, I don't know if this guy touched in here. This is the secondary side. This is the primary side. Uh, yeah, this these joints, I think, are this mauve. I guess this is a mauve, or I don't know. Uh, so yeah, maybe there's a problem in there. Hoping that this thing is gone. If it is, then it's an easy replacement. And the other joint that looks kind of bad in here, it's a diode, I guess. So if I turn it over, it's around here. So we have two diodes in there. I'm not quite sure if you can see, but yeah, there's two diodes in there. So I'm gonna have a look at them. There's also a circuit in here. I'm gonna see what this is, but yeah, those are the first things I'm gonna check. That's what the visual inspection at least tells me to do at this point. I don't know if these joints are looking bad just because this other guy touched them somehow, but well, I'll have a look and see. Okay, I took the mod off the board. I don't have a proper way to test this because I think, well, I looking at other videos and stuff on the internet, I think the most appropriate way to test it would be like with an insulation meter, with insulation tester, sorry, just so you can apply, you know, like 1,000 volts or something and see what it does. Some people like to test with the mood meter, just trying to measure the resistance. I don't know if that's enough of a test, but when I do that, at least, and I measure the resistance, it's not showing on camera, but the multimeter is overloaded, so it's not showing anything. It's, I mean, meaning the resistance is much more than many mega ohms, so should be fine. Anyways, what I'm gonna do now next, I think everyone might loves to blame electrolytic capacitors, right? So I'm gonna try and do that. I'm gonna remove these caps, which are Samsung branded, which we all, I mean, are famous for being kind of crappy. Yeah, I'm gonna take them off and measure them at least to see, you know, what the values are. They're supposed to be 330 microfarads. So let's see what I get. I do have replacement caps. Not a good brand either, I think. But anyways, I think I can just then replace them just in case, you know, just to see if it does any good. Anyways, let me take them off the board and measure them. Okay, before I remove the caps, I thought, well, let me try and do this a little bit more scientifically. Even though I'm no expert, I thought, well, let me at least try and measure some of the obvious stuff. So I plugged it in, and I tried to follow the circuit a little bit and look at an ATX power supply, typical schematic, just to kind of get a grasp of things. I can tell I understand it very well, but anyways, I can measure just a few obvious things. I have my mood meter here in AC, and I can see that I mean, voltage is coming just fine. I have measured it at some points, but just to illustrate what it is like, I mean, it's 127 volts, which is what it is supposed to be, spot on. And then I thought, well, let me just go the places I know what they should be doing at least. So if I go to the bridge rectifier, first thing I thought was interesting is that, you know, if I go to try and measure the AC voltage across the legs where you were supposed to see the AC voltage, and let me probe that here, I get nothing. But then I follow the schematic a little bit, and if I take another reference, for example here, it is being fed with AC voltage. And then I look, there's a jumper across the two terminals where you typically put, like, you know, your two phases, or, you know, your mains voltage. So they're using this bridge as a, not as a full bridge rectifier, but just like a simple diode rectifier. I don't know what they're doing that, but anyways, but then, well, let me continue then. If I go now to measure DC, and I measure it across the minus and plus terminals here, you see nothing. So, and nothing AC as well, just in case, just to see if there was something weird going on. I did measure this bridge. Yeah, I think the bridge is gone. So because we're not getting anything out of it. So, and of course then nothing else works. So I think I'm gonna desolder this bridge now and have measure it and see what's going on. So yeah, I think that's a bit more scientific than just desoldering the caps and blaming the good old caps, as everyone does sometimes properly, but this time I was just taking a guess. So yeah, let me do that and come back. Okay, so I took the bridge off the board, and now let me try and test it with my multimeter. So if I go minus to plus, I should get two diodes, right? So zero point 0.9, that's about right. Now if I go between, and that's two, yeah, that's actually four diodes in parallel, right? So that's actually a good way to test all four diodes all at once. But let me just run a couple more tests. For example, if I go between minus and one of the AC legs, I think I should see one diode, right? I got one there and one there. So between one of the legs, yeah, either ways I get one, okay. And if I go to the other leg, other AC leg, and plus I get two diode, one diode again, yeah. So that's all good. Yeah, the bridge is good. It's not the culprit it looks like. So let me continue to look around and see if I can find anything else. Okay, I thought, what the heck? I have my soldering iron heated up, so I took the capacitors off as well, just to test them, just in case. And let me just do that right now. So just give it a scrub, just make sure it's a good contact. Here. So that's measuring 380 microfarads, sorry. And it's supposed to be 330 microfarads. So that looks good, I guess. Let me look at the other one now. Oops. And give it a few seconds to stabilize. There we go, 372 microfarads, fairly similar to the other one. So yeah, caps look good as well. I'll have to find another UT part. Alright, so as you guys saw before, I tested the diode bridge. The problem is not there. The problem is not in this capacitor. It's not in the diode here. It's not in this MOSFET that I replaced anyways. So I started looking a little bit more, and there's these other two MOSFETs. And coincidentally, I found another video of someone who had trouble with these MOSFETs when they did the exact same thing as I did, which is plug a 110 or 127 volts PSU in a 220 volts mains outlet. So I'm gonna have a look at these MOSFETs. I measured them on circuit on board here. One of them is measuring like high impedance, like 39 mega ohms or something. I'm still not quite sure if that's good, because I'm not quite sure if my multimeter here should be able to get any reading. But anyways, but the other one seems to be measuring like 0. So well, I doubt there would be like a shorting jumper or whatever around in parallel with this MOSFET. So if I'm measuring 0 ohms there, it's very likely this is defective. So I'm gonna have a look at this. I'm gonna take them out of the board and check them just to make sure. But yeah, I might have found the culprit here in this MOSFET. It doesn't show any physical side of physical damage signs here. I mean, at least I cannot see them in while it is still in the board here. So I'm gonna take it out and measure it and see, what I find. But yeah, might be this one here. Let's hope it is. Well, looks like they are fine. As I said before, I do not have a proper way of measuring MOSFETs, but if I try to measure their resistance at least, let me try and do that under the camera here. For this one here, I get, hold on. Yeah, I got basically an open circuit, so which is fine, let's say. And the same for this one here, if I'm not mistaken. Yeah, so not much in here. Some people also say to use the diode test, so let me try and do that, both sides, but I think that's not gonna do anything as well. So yeah, nothing like this, and nothing again. And same in here. So yeah, looks like the mobs are good actually. So um, what I'm thinking now is that, I mean, the symptom, or the most obvious symptom I get is that the breach is not out. There's nothing in the breach output. So there's only two reasons for that. One, if it wasn't being fed with AC voltage, and two, if there was no current flowing through it. So I'm thinking uh, is the second option there, because I do know that the AC voltage is getting there. So I'll just have to probably have a look at these fats here and see if they maybe are faulty. But yeah, I'm getting to a point where I have looked at most of the components in the primary side, and probably if I test the fats okay, I'm gonna give up on this. I'm not quite sure if it's worth doing much more on this. What I had in mind for this power supply basically was to replace it, some of the various power bricks I have in my TV room, with just one single PSU and multiple outputs. So I was gonna do some add-ons to it. But if it's too difficult to fix, I think it's not gonna be worth it. So let me try and have a look at these fats, and then we take from there. Okay, finally, I think I found the problem. So yeah, as I said before, I should have looked at the MOSFETs before. As soon as I realized that there was no current flowing through the breach, I should have looked at the MOSFETs. But yeah, living and learning. So what I found is that these are 12N50E Fujitsu power MOSFETs. Let me see if I can get the close up here. Yeah. So the pinout is gate, drain, source. So if I try and measure the resistance across, so let me just take gate here, for example. Oops. Yeah, so that one is on the gate, and if I try to measure resistance to source, for example, 0 or close to 0, and 1.8 ohms. So yeah, basically shorted. And the drain source are also shorted. So here and there, it's also shorted. So sorry for the glare. So and it's the same with both MOSFETs. So they are clearly fried. All right, it's a couple of days later, and I couldn't find exact replacements for the original fats, so I bought these international rectifier IRFB 13N50A, which are very similar spec-wise. They're same pin out. They can take 14 amps as opposed to 12 amps that the original ones can take. Uh, VDS max is 500 volts RMS, so that's also a match. And VGS threshold is also 3 volts. This one is a bit tighter. It's like 3 plus minus half a volt. This is 3 plus or minus 1 volt. So 2 to 4, 3.5 to 4.5. So to 3.5. So yeah, very similar. I was gonna replace the MOVs anyways, just because they were supposed to be protecting the fats. When I look at the board, then later I realized that that's why I measured one of them shorted when they were still on the board, because they were across the MOSFET legs. So and they didn't do their job. So I was gonna replace them, but I couldn't find a replacement which would fit there. So I would do. I will either leave that unpopulated, which is maybe not ideal, but it's okay, or I'm gonna just put them there again, anyways, and hope for the best. So yeah, I'm gonna solder these guys here. The only thing is that they have their back exposed and connected to drain. These are isolated, so I have to buy isolators, and I forgot. So I'm gonna just put them in place, not touch the heatsink, and just test the PSU unloaded, hoping it's gonna come back to life, and then I can put an isolator there and finish the job properly later. But let's just see if it works first. Okay, FET's in place, moment of truth. I'm gonna plug it in, and if all goes to plan, a little LED is gonna turn on in here. If I remember my Xbox power supply, it's gonna be red, or no, sorry, it's gonna be orange. And then if I had the Xbox plugged in, then it would turn green. Uh, let's see. Or it could also turn red, showing that there's some issue, but at least the thing is working. So let's see. Fail. Oh man, this is turning to be a lot of time for nothing. So let's at least see if it did any good. The most obvious symptom I was getting before is that there was no voltage output at the bridge. So let me see if at least I get something there. Hold on, let me just get my probes. Okay, so I have my multimeter here measuring DC, and if I try and probe the output of the bridge now. Ah, that is interesting. I at least get something out of it now. Let me see if I can put the multimeter here somehow where you guys can see it. So if I measure that now, I'm getting like 2.8 volts. I got the probe swap, but anyways, and it's rising. So, yeah, it's definitely doing something different than it was before. I just don't know what. So I'm gonna have to further work on this. Or, well, I had said before that if the FETs alone didn't work, I'm not quite sure if it was worth spending too much time on it anymore. So I'm gonna give it a thought and see if I do any more troubleshooting. If not, I'm gonna just upload this video where it is right now and maybe come back to it someday. But I can see that I was maybe getting closer. The FETs definitely did some good. So I just have to see what else is not working here. So yeah. All right. All right, so I was editing the footage I have already shot for this repair attempt, and it's quite long already. So what I decided is that I'm gonna stop for now and upload the video. And as you guys saw, the FATs did get me closer to fixing this thing, I guess. But I just needed to take a break from it, so I think I'm gonna come back later with a part two video or something where I hopefully actually fix it. But otherwise, it was a very nice learning experience so far. So I think I'm gonna come back to it later, but just in another video. All right, thanks for watching.